G'day, Lockie here. I am still reeling and sifting through all the great announcements from KubeCon this week, and I was really excited to get my hands on the operator framework and do an unboxing. So the operator framework, Brandon Phillips announced from Red Hat earlier this week at KubeCon that they have an SDK and some other tooling around making Kubernetes operators easier to create and manage the life cycle of those operators. So I thought, let's dive in here and take a look at what we got. If you want to do this from home, you can go to github.com operator-framework. Now there's a couple of things in this org at the moment. There's a lifecycle manager, we will go into that. Getting started, the operator SDK, some other samples. And if you're new to operators, here are some great operators in the open source community that you can get your hands wet with. I haven't actually played with the Helm app operator toolkit. You will see that a little later if I revisit this. But one of the things I wanted to do was just show you really how easy this is to do. So if you've ever written a Kubernetes operator or worked on a Kubernetes operator before, there's a lot of boilerplate code. So there's informers, there's all this kind of how do I cache information, how do I handle updates, how do I handle all this interactions with the Kubernetes API and version that over time. So as Kubernetes APIs change, do I have to go and refactor my code, my operator code? This is about making that abstraction much more lightweight. So I'm very excited to see how this works. If you, I'm going to walk you through the demo here just to show you just how easy it is. But all I have done is gone to the operator SDK and actually followed the directions to install it. And I've also gone to the operator lifecycle manager. I'll show you that, and that just gets installed here. There's an install guide, but you just they publish a manifest for that. I'll go into what operator lifecycle manager is, but let's just pop over to the getting started repository here. This is great. It walks you through soup to nuts, getting something up and running, and even shows you how to do the operator lifecycle manager. So I'll go into that in a minute, but let's just start. I am going to walk through this and show you how it's done. So you can see here, let's go to a go path source GitHub and create a directory. I'm going to create a directory called the memcached operator. So, okay, so what we're going to do is use this operator SDK new. What this does is create the scaffolding. So here we go. So in my GitHub user, I'm going to create an API version cache.example.com v1 alpha1 kind. So this is going to create all the scaffolding for that. Okay, so what do we got going on here? Create all these scaffolding artifacts here. We're running a dep ensure, so we're pulling down the Go dependencies, vendoring them in. I'm going to open VS Code here. And see what we got. Okay, so we do have Go package lock and toml there. We have, looks like the main here, so the entry point to the operator code, config. This is around the API version kind and the project name, a little metadata there. It looks like we get a custom resource. It looks like that based on the name. Some RBAC. And here's where the APIs are defined for that v1 alpha1 API and a stub handler vendoring and a temp directory there. Fantastic. So let's pop back over. So with one command, we've defined an API version and a kind, and all the scaffolding is there. Let's pop back and take a look at what we're going to do here. Jump into that directory, customize the operator logic here. So we will go ahead and do that. And what we will do here, define a memcache spec and status. Okay, so in the v1 alpha1 types here, we're going to define a struct called the spec and the status. Okay, so the size and the node names is what we must really be interested in. So let me take that. This is, again, just walking through this example. Register.go. Okay, I think that's fine. Types.go. Okay, so these are these two we're filling in here. Okay, so we have an int32 for size and a slice of strings for the nodes. Okay, we are good there. And what does this do? Okay, update the generated code for the custom resource. So we run this. Okay, I've got to go into the right directory. Okay, so running code generation for custom resources. So obviously because we've created the size and the status of the node names, it's going to go and regenerate, so generating the deep copy function. Okay, fantastic. So now my code is in order. Build the operator. Okay, so we didn't do the define handler. So there's a stub handler in there at the moment. We have a reference here. Now this is where all your logic goes for your operator. So what do we got here? Handle, and inside handle we have, okay, deployment for memcache. Okay, fantastic. So this is just a cookie cutter. We can take this, grab it raw, and throw it in as the handler. I'm not too concerned with showing you that at the moment. I'm just showing you how easy it is to get. So this is where you would put all your operator logic if you were building a new. I'm just going to go and fix this up. And operator framework. Okay, so that's that. Fix up the imports here. Fantastic. Okay, so my logic's there. Again, this is a great scaffold and great, this is building just a demo memcached operator. Okay, going to go back. All right, so we have that done. Okay, so now I'm just going to build this. Okay, operator SDK, build it. Example, I am just going to push to my Docker Hub. So I will tag it like that. Okay, the other thing that I think this does is actually generate the deployment artifact as well. So in here we have the RBAC, we have the custom resource definition. Role binding. Okay, so we do have this operator. Okay. Here's the custom resource definition, namespace, the version, and here's the deployment for the operator. Okay, fantastic. So that looks like it is done, successfully tagged. All right, Docker push that. So now it'll be up in the repository. Okay, this is all, for those who have written this, this is incredibly difficult just to get that boilerplate code unless you're quite happy with it. Now, I'm going to skip over this. This would actually go out and deploy what we just, actually, let's go ahead and do it. So this is going to deploy the RBAC. RBAC created, and this is going to deploy the operator that we just scaffolded it and built. Kubectl get pods. So we're up and running. So I have gone 0 to operator, deployed on my cluster in no time. So obviously the scaffold, and I took the handler, which is all the logic, but all the interactions and all the boilerplate interactions with Kubernetes API and what to listen on, that's all done right now. This is all done. Now, I'm going to move on to the lifecycle manager here in the interest of time, because I think this is really interesting as well. Now, I mentioned that there is lifecycle manager, I've just cleaned up there. Lifecycle manager, so it's like who operates the operators and how do you take care of operators over time, because presumably the code inside the operators is changing as well as the clusters. Let's say I want to add some new logic, how do I go about that? There is the operator lifecycle manager here. Go take a look at it, but this project does not replace Helm or turn Kubernetes into a PaaS. I like that they called that out. All right, so what we're going to do here is actually generate an operator manifest, and this manifest describes how to deploy, create, upgrade, and all the metadata around my operator so that I can deploy it onto a cluster and manage it. So what we do is there's a sample operator here, and I've been having a little fun. So this is a curl command. We're going to chuck this in deploy. Okay. So what we have here now is this memcache operator 001. Okay, so there is a kind here called cluster service version. So this is a service catalog kind of setup here of all your operators. And this tells us, as I said, how do we deploy this? Where's the deployment? What's it look like? What are the resource definitions? Who owns it? Some keywords and some metadata around it. So presumably there's a place that I can actually take a look at all these different operators and manage them over time and make sure that it's all up and running okay. What I'm going to do is actually go to the operator here and copy from my operator.yaml here and move it over. Move it over here. Okay, I'll take that out and just dump this straight in. Okay, so we've got the containers there. Right, was that at the same indent? Yes, we are one in from containers. All right, so let me just put that back in and move it over here. Okay, so that's my operator in there. Okay, so what we're going to do is just apply that operator now. Okay, kubectl apply -f, deploy memcached. Okay, so my cluster service definition there, the service version for memcache. So this is about application lifecycle management and pertaining to my operator, right? So at the moment I don't have an operator running. I could have deployed it before, but I didn't. I'm using this operator lifecycle manager to actually take care of deploying the operators for me. So there's no operator at the moment. There are, so kubectl get pods in the tectonic system namespace. I have deployed this beforehand. So we have an ALM operator and a catalog operator here. They're both working and functioning. These are actually the things that are going to take care of deploying the my memcache operator for me here. All right, so what is actually happening is I am going to deploy this. I think I just did that, so I can actually go and grab a status here. Okay, so it's actually looking, the way this works is it's actually looking, so it's in pending state because the requirements are not met, because it's not seeing a custom resource definition called memcached.cache.example.com. So as soon as that custom resource definition is created, this is actually going to go and create the operator based on that service manifest I just deployed. Okay, so in this step, that's actually what's going to be triggered. So I'm going to just deploy the RBAC again into the default namespace. And this command is going to take out anything in the operator deployment on the bottom after that ... Okay, so we're just going to apply the custom resource definition. Now this is going to trigger some behavior inside that application lifecycle manager that's going to create a deployment, because it's going to say if this custom resource exists in this namespace, then I'm going to need an operator to fulfill that request. So let me go back and grab the command here. Okay, fantastic. I've created that. Get CRD, kubectl get CRT. There we go. So we have this. Now I would expect there to be an operator for 9 seconds. So based on the fact that I have just defined this CRD, I have fulfilled the requirements for ALM to actually go and deploy, and it has the details on how to deploy that operator. Right, so kubectl describe. You should be able to see that that's up and running, and it's running my operator at version 001. Okay, now finally, let's just go and test this operator. So I'm going to create a custom resource here for memcache for WordPress here. This is in the default namespace. Okay, memcached. So we can see that we've created that. The operator should be actioning that, and I should have a memcache for WordPress. So the other thing I could do is edit this. Edit. Let's go ahead and, right, and remember we have the status and the nodes that we defined in our types inside our operator. Okay, I'm going to bump it to 2. What we should see is, yep, okay, so now I have a 2-node memcached cluster there based on that. We could then go and create this other one for Drupal. Let's go ahead and do that. And I should have a Drupal cluster here as well in this namespace. or yep, there it is, it's up and running. Fantastic. So now the last thing we would want to ever do here is actually update the operator. So let's go through that. I'm going to pull down this file again into the deployment directory, memcached operator 002. Okay, so we have, this is exactly the same, but what I'm going to do is copy this over into this. The only thing I'm going to change is I've already built and deployed 002. It's the same actual source code as 001, but this is how we would life cycle the operator itself. Okay, so let's go ahead and deploy that. And actually, why not down the bottom get pods? Let's do a get pods -w, kubectl apply -f, and we're going to do deployment. And we're going to do memcached operator 002. So this is simulating me updating the operator using the operator lifecycle manager. Apply. Here we go. So you can see that it's kicked off. Okay. Kubectl get pods. So we have a new operator running here. Kubectl describe. We should see that it's at 002. Describe. Yep, v002. So I have simulated, I've made a code change to the operator itself. I've updated the cluster service version for that operator to 002, and the operator lifecycle manager is actually managed. So I've gone end to end through this demo. You can see how easy it is to actually create a brand new operator and scaffold it out. So I'm excited about seeing a whole new bunch of great operators out there, given that this is that easy to do. And happy operating. And thanks to the folks over at Red Hat and CoreOS for actually creating this. I think it's going to open up a world of new operators, new custom resources that folks can actually get more out of Kubernetes with custom applications. So thanks for watching, and if you enjoy, please subscribe or feel free to give me feedback. And thanks for joining. Cheers. Bye.